In the last video, we talked about the importance of SPF and how companies seem to lie to you. If they put too high of an SPF on there, it's really just a waste of money, a way that they can maybe ink out a couple of more dollars from your wallet when you decide to buy the sunscreen. So I told you in this video we're going to talk about chemical blockers, and this is what we're really going to be focused on. In the last video, we mentioned two different classifications, chemical blockers and chemical absorbers, and this is actually a term that probably is not really proper because these compounds are not blockers, but they are absorbers. Okay, so the blockers are really zinc and titanium, and absorbers are going to be a different type of classification. And what you're seeing on the screen right now is one of those classifications or one of those molecules. And this molecule is going to be called oxybenzone. So this is what this lab is going to be focused on. We are going to look at sunscreens and we're going to extract the amount of oxybenzone, if it has any, from that formulation, and we're going to inject that onto an HPLC instrument, and we're going to measure how much oxybenzone really is present in that product. A little bit of organic here. First, you're looking at these rings, and the rings have this alternating double, single, double, single, double bond all the way around them. This is traditional for delocalization, and delocalization makes the molecule very stable. Not only do we have delocalization here, but that single double can also go up into this double bond O structure. So that increases the stability of it even more. In addition to that, if you look to the left, you're going to see another ring, and this is another area of delocalization. So we get more stability from this ring. And then up here at the OH group, there's actually understood to be two sets of electron pairs there, and this can also go up into the OH area. So delocalization's all over the place, people, and for that reason, this brings a very high stability to the molecule. In addition to that, delocalization typically allows molecules to absorb UV light energy. Go figure. This is one of the reasons that we use it in sunscreen. So I can take oxybenzone and I can make a solution of it, and I can run that solution on a UV. And I would know that this was proper for UV just by looking at the functional groups and the delocalization that is present in the molecule. I know that it would be absorbing UV light energy just by looking at the structural characteristics of that molecule. Well, if it absorbs UV light in a UV vis, then why not put it into a cream or a lotion or a spray so it can absorb UV light when it hits your skin? And that is what we do. Oxybenzone's only one of these choices. There's actually multiple different versions, or what we would call sister or cousin compounds to oxybenzone, and you're going to see quite a few different ones that are going to be used in these sunscreen formulations when you begin to take a look at the ingredient label. This is also classified as a benzophenone, and benzophenones make great compounds for this. All right. What is a benzophenone? Well, benz is going to represent the benzene. Phenone is actually going to represent this whole grouping here. So think of these two benzene rings connected by a C double bond O. And this C double bond O is a ketone group. And this is why we call it benzophenone, right? You can think of the word phen for phenol, and that phenyl group is actually going to come from that OH group. So that whole grouping or cluster of carbons and hydrogens is going to be called a benzophenone. So tons of different molecules that are very strongly related here, and oxybenzone is just one of them. Oxybenzone also plays multiple purposes. You just don't find it in sunscreen. You're going to find it in tons of other products that want to block or absorb UV light. So very commonly, it's sprayed on plastics. It's sprayed on toys, especially ones that you would put in your front yard or your backyard. This prevents color fading over a course of time. They spray it on furniture for the same reason. You don't want your furniture to start to change color over the years as UV light energy begins to hit it. Hairsprays, any kind of leave-in conditioners typically have an oxybenzone or related compound in them, and the reason there is because UV light can change the color of your hair if you're not careful, especially if you like to color your hair a different color than its natural state. So all of these products are going to be commonly found out there on the market that has something like oxybenzone on the inside. It's not just sunscreen here. They use it for multiple purposes. Oxybenzone also does a great job to absorb UV light in the A and the B region. So when this whole move happened to start making these formulas that would have absorbance in both of these areas, oxybenzone was a great step forward at the time. Studies had been done on oxybenzone. It was already approved. It was grandfathered in to the sunscreen industry, so they were able to use it without a problem. It was approved in FDA about 1980s, and the FDA actually went back and revised it. They took another look at oxybenzone levels in these formulations, and they said, listen, we're going to put a limit, and this limit's going to be a 6% concentration limit. After that, you can't use any more than that. You're going to have to use a different alternative if you need more. What are some of these other compounds that I keep mentioning? Well, here they are on the screen. Oxybenzone is, again, the one that we're going to be looking at in this lab experiment, but you also have a sister molecule called avobenzone. And if you look at the structure, you're going to see very similar characteristics. They're not exact, of course, right? But they are very similar. You see two benzene rings. You see an OCH3 group here. You see some double bond O characteristic up here in the middle. The difference, or one of the differences, it has an extra one. And then over here on the right-hand side, it has this tertiary carbon cluster that sits over there. A couple of different ingredients, all very common in sunscreen usage. Again, though, we're only going to be focused on oxybenzone here, and that's it. If you take a look at the ingredient label of a sunscreen bottle, this is what you're going to see. Up here in the top left-hand corner, you're going to see the active ingredients that are going to be listed. Notice oxybenzone is listed here, and look, folks, they pushed it up to the max limit according to the FDA at this point. So 6% was as high as they could go, and then they began to go to other sources and start incorporating those to improve the UV absorbance of their product, and this one was SPF 55. All right, this is Neutrogena, or Neutrogena, by the way. So just because it's a fancy little label that you pay a lot of money for, they are still using these chemical additives into their sunscreens. Here's L'Oreal, and if you look at the ingredient list, you're also going to see oxybenzone that's going to be listed. That oxybenzone, again, is at 6%, and we now know why. And they look at these other sources for UV blockers to up the ante of their SPFs. And this one just so happens to be an SPF of 30. Notice that this Neutrogena product is below 60. FDA encourages you not to make anything above a 60 because now they are publishing data and articles that say it's not going to do you any good. So they just so happen to be below the 60 mark. Here, L'Oreal just so happens to be an SPF 30. And then here we have another sunscreen, and it says SPF of 36 zinc oxide, right? And zinc oxide is one of those ingredients that we said was used very, very early on, and this was an actual blocker. It ricocheted the UV light off. It did not absorb it. So this is tried and true stuff. We have had this for years. There's been numerous studies on zinc oxide and titanium dioxide. All of this is perfectly safe. It is used for multiple purposes, but yet we still want it to include these chemical absorbers as well. Don't let this product fool you, though. It looks kind of all fancy from the label, but when you turn it onto the back, look up here at the very top, you're going to see active ingredients, and you're going to see oxybenzone as an additive ingredient for that, 4.7%. So just because it says zinc oxide on the front, and if you are one of those people that want to stray away from the chemical additives of the sunscreen for the benzophenone family, then here this is somewhat misleading, because you're still going to get it in the very end. They just don't put it on the front, but they put it on the back. All right, so what's the story with the sunscreens? You know I'm going to lead up to something, right? I mean, what's the deal here? I keep talking about sunscreen. I keep talking about blocking UV rays. I keep talking about chemical additives. I keep talking about people not wanting to purchase those chemical additives. Well, here's our first ban. Hawaii state legislator says we're going to prohibit the sale of non-prescription sunscreen containing oxybenzone. No more. You go to our stores, no matter where, you're not going to find any sunscreen that has oxybenzone in the formula. Sorry, folks, you got to sell your product somewhere else. Okay, so the question here is why? What was so big about this? Oxybenzone, of everything, and sunscreen, people slather it on their skin every day. What's the big deal? Here we have another ban. Key West, Florida. They banned the sale of sunscreens that contain oxybenzone, and this is effective in 2021. No more. 2 people have now enforced bans on sunscreens that contain oxybenzone. This oxybenzone has been used in sunscreens for years and years. It's been used in sunscreens. But now all of a sudden they don't want to sell it anymore. They're going to prohibit it. And they're going to take you back to a time where the zinc or the titanium are going to be used. And these, again, are the chemicals that give you that white sheen when you decide to use them. Why? Well, the issue here is that oxybenzone, the way that this started, was affecting the coral reefs in these areas. If you can imagine, all of these tourists go to Key West, they go to Hawaii, and they slather on the sunscreen because they're going to spend a large part of their day outside. Well, when they slather on the sunscreen, this is a lotion-based. Some of it does absorb in your skin, but, you know, we really wanted to stay outside on the surface so we can have that blocker, like those pictures. It blocked the UV light. Well, then they would dive into the water, and over and over and over, day after day after day, and the hundreds of thousands of people that are there that have slathered sunscreen on their skin, we started to see this that happened to our coral reefs. So December of 2014, this picture was taken. This is very healthy. You can see it. It looks alive, right? Notice how light brown and stuff these are. I mean, that's kind of the sign that you would want to see. Color. 2015, just 2 or 3 months later, that's all it took. We now have a dying coral reef. We call this bleaching. Bleaching was happening to the coral reef system. And then a couple of months after that, we now have a completely dead coral reef system. So something was causing this. We started to see it happen more and more and more. We started to see it happen in more of the touristy areas that had more people in it. So they scratched their heads and they said, well, okay, we got to figure out what's going on. What is causing the bleaching of the coral reef system? And what they discovered is that the DNA of the coral reef system was actually completely changed. The DNA was modified. And this modified DNA, now what was going on was that the sunlight would hit the coral reef system and it would basically do the opposite, right? We use sunblock to basically prevent the sunlight to do damage to us. The coral reef system built up its own immunity for this. However, the bleaching aspect is this concept that UV light energy is now hitting the coral reefs and it's damaging it. No longer do they have this built up, this immunity in a way to the sunlight. Well, their DNA was changed. The DNA was changed because of oxybenzone. There was a direct connection there. Now, I know that other factors can cause the decay and the wipeout of coral reef systems as well. But oxybenzone was specifically found in the coral reefs that underwent this bleaching mode of their life. Completely wiped them out. Well, you're telling me that people slathering sunscreen on their skin would have this effect? Kind of. Because this actually happens at 62 parts per trillion level. Okay? Parts per trillion. Most of the time, we work on part per million level. This semester, we had one lab where we went to part per billion level. Imagine how super clean we had to be during that time. Part per trillion is another level below. Super tiny. And it's going to tell you down here, if you need to kind of reference that, that's 1 drop of water in 6.5 Olympic-sized swimming pools. Meaning, it took 1 drop of oxybenzone in 6.5 swimming pool sizes to kill out those reefs and to bleach them. That was enough to basically venture over, get incorporated and change the DNA of the system and completely wipe them out, completely kill them. Not only that, but it's also targeting the aquatic life. We actually have studies now that show that oxybenzone does funny things to things like fish. And we also have studies that show oxybenzone does funny things to humans. Oh, okay. So oxybenzone put in sunscreen, sold to a human legally. We slather it on. We slather it multiple times during the day, all summer long. It kills out coral reefs. It affects the aquatic wildlife. And now you're telling me that it's going to affect me as well? Yeah, that's what I'm basically saying. Well, oxybenzone is not the only one that's doing it. Remember I told you there was a chemical soup. There were sister compounds that are involved in the ingredient label. And if I go back and show you one of those sunscreens, here we go. You can see what's here. Oxybenzone knows only one player. Oxybenzone was specifically found in the DNA that's been modified, though. But oxybenzone's only one player out of the bunch. It's bringing to the party all of its buddies as well. All of these are contributing factors, every single one of them. Not only was oxybenzone coming from the sunscreen, but you can imagine all of the people that didn't go into the water. What do? They go home, they go to their condos, they go to their hotels, they take a shower, they wash it all off. All of that oxybenzone goes down the drain, and it's got to go somewhere. And that somewhere is wastewater. That wastewater has to be dumped, like it is most of the time anywhere else. And all of that compound does not get treated. It's not meant to treat oxybenzone. It's meant to treat other things. Oxybenzone's not one of them. And all of that waste, all of that sludge goes out. That increases the levels of oxybenzone even more. So if you're not getting in the water, and if you're not swimming in the coral reefs, or scuba diving, or whatever the case is, snorkeling, If you're putting it on in those areas and you go to your hotel and you take a shower, you are contributing to the disposal of oxybenzone and its family of molecules into the system. Again, part per trillion level. That's all it takes. Then, I just told you, not only is it toxic to the wildlife, not only is it toxic to the coral reef systems, National Toxicology Program, oxybenzone shows equivocal evidence of carcinogenic activity. Okay, I'm going to read that one more time. NTP, oxybenzone, shows equivocal evidence, equivocal meaning equal evidence of carcinogenic activity. Carcinogenic means cancer. What? Read the summary. An NTP rat study linked oxybenzone to equivocal evidence of carcinogenic activity. And it's a reminder of how the industry may have to climb after this point in order to get this compound as generally recognized as safe and effective under the FDA review. That's GARS. Well, FDA does safe and effective, so S and E are at the end. So basically what this study is saying is that you have been sold sunscreen all your life. You have been told to put sunscreen on your entire life. Whenever you go out in the summer, whenever you go out to the beach, whenever you go out and expose yourself to UV light energy, you are putting the sunscreen on to prevent damage to your skin. This damage, in part, is melanoma. It is skin cancer, tumors. But yet the product that you're using is also directly related to cancer. What do? Sunscreen slathered on your skin to prevent cancer from the sun, or sunscreen slathered on your skin getting cancer from the chemicals that's on the inside. Now you know why I've made a couple of these comments about zinc oxide and titanium and no use of chemical additives for the sunscreen. This is why people stray away from them. The studies just really aren't proven yet. A consumer product that's been sold to us for years, that was basically grandfathered into a system that said it was safe and effective, now has its first study, or one of the first studies, that says that it could possibly be linked to cancer. That's a doozy, isn't it? Bet you weren't expecting that one. According to the draft report, 1,000, 3,000, 10,000 part per millions in concentration was given to a rat population over a 2-year period and compared to a control group. Investigators observed brain and spinal cord malignant cancer tumors, basically, in male rats, and uterine deformities and tumors, polyps, in female rats. What aren't they telling us? Why isn't this on the news? Why isn't there more of a concern with this? Well, in certain groups, in certain populations of communities, people know about this. Is it mainstream? The answer is no, not yet. But here we get an idea that something as simple as sunscreen could be causing cancer in people under the wrong circumstance.